Okay, we have the furnace going, and at this point what we need to do is measure the amperage of this gas valve. How many amps this gas valve's pulling, that's how we determine what we set the heat anticipator on our thermostat. You can do that up at the thermostat, or you can do it where the lead's hooked to the furnace. I do it here, it's just a lot easier than pulling the thermostat off the wall. So I set my anticipator for amps AC. Okay, so I'm going to read my amp readings on this right here. I have 0.4748. So I'm going to set the anticipator. It's going to be about 0.5 is where I'll end up setting it. So we'll go up to the thermostat now and we'll take a look at what that's set at. Okay, so let's see what our anticipator's set at. Looks like it's a little over 0.4. I'll move it out of the way here so we can see. Between 0.4, 0.6, we want to be right here. So it looks to me like it's set about right. We'll just get it right up there to 0.5. And that should be set. That make sure that the thermostat turns off a little early so that you know how the fan, when the thermostat turns off, that fan still runs. So that anticipator sets it up to where this turns off a little bit early, and then that fan runs a little longer, which keeps putting heat into the house so that we don't overshoot whatever temperature we're set at. Okay, at this point I've removed some screws. I want to look into the burner and the burners and the heat exchangers. I'm looking for cracked heat exchangers. So I could pull the whole burner assembly. This is a little easier. And then these are the individual burners on this unit. They're a little different type of burner than what you're going to see on most furnaces today. These are they're a mono port and a ribbon, kind of a hybrid. Okay, these are the two ports where I had the high CO, and I'm actually going to look up into every single port, but I'm going to really spend some time on these, seeing if there's anything cracked in the heat exchanger. And so I can look, right into these ports, and I'll also take a mirror like this. I'll stick it in there and use my flashlight to try to see, if there are any issues or cracks is what I'm looking for in this heat exchanger. See that buildup in there? Up above there's buildup. This one's pretty clean inside. So that one's clean, that one's clean. We got a whole bunch of stuff building up in here. And this one looks pretty clean too. This one definitely, something's going on here. I'm actually going to have to take part of that flue off. It's like opening a present that never ends. So the tape was covering up Somebody must have cut a hole in here for some reason. I have no idea what, but this tape, literally duct tape, is just covering up that hole. This 90 needs to be replaced right here. Yeah, I'm guessing at one time this had a different water heater in it, and somebody actually poked the water heater, flew right into this. Okay, now we can look into these top ports of the heat exchanger. Okay, I actually don't visibly see any cracks. I don't see any like black soot. This powder here is more from it's not necessarily a bad burn. It's not a soot. A soot's going to be greasy, oily. I'm going to take this plate off and just see if I can see anything else in there. See any cracks? Yeah, I just don't. Any signs of the cracked heat exchanger. And the last place that I have an opportunity to look is underneath through the fan, where the fan sits. Back to our flue. What we have here is a T. It's not even a T, it's a homemade T. This is just a piece of pipe where someone cut a hole in it and then bent the tabs off to make a T. And the problem is I need about 1.5 inches for this to go up inside of here, which would cover a part of this. So what they did was they cut out part of this fitting here. And so when you put this back together, just to show what they did, this needs to be installed correctly. Then you can look up inside here and you see how the T goes into it, but it's not correct. It's not even really, it's a homemade T, and the tabs are in the wrong direction for the flow of the gases. What needs to happen is this needs to be a little shorter. A real T needs to be put in here, and then we tie into this. Okay, these are drill bit orifices. While I have this all tore apart, since we're getting a lot of CO, I can't find a crack in the heat exchanger. I haven't looked down below yet, but I just want to confirm that my my burner orifices are the right size. So I have a bit here, and I get my size. Without having to take them out, I can use my bits. This is a number 33 orifice. Okay, so I'll go to my charts next and see what how many BTUs a 33 puts out. I'll take that times 4, and I should get the 138,000 BTUs. 1,000 BTUs. Okay. So 33 orifice on my charts. I'm between 800 and 1,000 BTUs, but I'm closer to 800 BTUs per foot, which on the low end is 28.8 and the high end is 36. So I'm real close to 30,000 BTUs per orifice, and I have 4, so that's 120,000 BTUs. through here, and my boiler is 138, so which at my altitude I needed to be about 110. So they're still a little big, but not very big. They shouldn't be kicking out the amount of CO that I'm seeing, so I don't think that's the problem. I still need to check my gas pressure though. Okay, at this point what we're going to do is check our gas pressure, our manifold gas pressure. It should be around 3.5 inches of water column. I've already loosened this up so I can pull this out. I'm going to pull this plug out. I'm just going to set it right here, and I'm going to put my tubing gauge tubing in here. I'll just snug this up a little bit. Okay, so I got that snugged up, and I'm going to hook this to my pressure gauge here. I'm going to put it to water column. I'm going to zero it out, and right now I have 0 inches of water column. Okay, and then I'm going to fire this. We're going to see what we get for a reading. Like I said, we want to be about 3.5. I need to light my pilot light, so I'll turn my pilot gas on, hold the button in. Pilot's lit. I can turn my gas on. I believe I still have my thermostat up high upstairs, so I should be able to turn this on. Okay, so now I am actually seeing part of my problem. If you look at my water, my gas pressure, it's really high. It's at 4.21. It should be 3.5. Okay. So now I need to adjust my gas pressure. I'm 99% sure this is causing my problems with high CO. So I'm going to go to my regulator here, if I can get to it, and try to make a gas adjustment. Drop that down to 3.5 inches of water column. And actually, you can hear the burners start to settle down. They're not as loud. So this thing was overfiring, sending a lot of raw fuel out. Okay, there I got my gas pressure down to 3.5 inches. What we'll do is we'll turn our gas off now. Let this thing cool off, and then we'll also, this will probably help with the flame rollout that was occurring. So what I'm going to do is I'm going to disconnect this, put my plug back in, and we'll fire it back up. Okay, we're just putting a little patch on this while, you know, we got to do a little more diagnostics, but ultimately this is going to get prescribed for a full-blown replacement. This is just a patch while we're working here. I'm using some aluminum foil tape to patch this hole up. Okay, we made the gas adjustment, and now we're going to see what our combustion analysis looks like. It should go down the first two burners. It makes sense. We had high gas pressure here, so the first and second orifice are going to see the highest pressure, which they're going to get the most fuel. It's going to drop off as we go down a little bit. Pretty sure when we put our meter up in here, our combustion analyzer, we're going to see our parts per million will have gone down. So we'll set this to read our CO, and we'll just go ahead and start in our third hole here. And voila, our CO is now very stable. I think this one was in the 400s at one point. Too much fuel causes that. Okay, we'll go to the next one. Let's see what the CO is doing in that one. And again, it's pretty stable as well. We're getting a nice number there as well. And let's check our first and second one while we're at it. Those were in the 40s, I believe. And there we have pretty good number as well. They're all pretty stable now. And let's go to our second hole. And they're all 12, 13 parts per million. Excellent. So we now have a furnace that is running really nice.